All right, so this is another problem that I will use to reiterate the points that we talked about this morning in terms of problem solving. So again, when you first are given a problem, you don't want to say, oh, I've never seen this before. I don't even have an idea of how to solve this. You want to, switch this around. Read the instructions carefully for clues, things you already know. And even if it's the obvious, it's good to start working from what is obvious to you so that you can find the things that aren't. Ask lots of questions. One question you should always ask about is inputs and outputs and about edge cases. So what kinds of different inputs the user might give that might break the solution and how you should encounter those. You should consider different approaches before you actually jump into coding. If you go with your first hunch, sometimes you may miss a more eloquent or efficient solution. Then you should pseudocode your solution once you have a general idea of what you're going to do. And then once you have that pseudocode, sometimes maybe once you've already coded it out, but before you try to run it, because during most interviews, you won't necessarily get to run the code. So walk through it line by line and see if the code is going to execute in the way that you expect. All right, so the problem that I'm going to solve right now is called nth Fibonacci. By definition, the first two numbers in the Fibonacci sequence, the Fibonacci sequence is a famous mathematical sequence, are 0 and 1, and each subsequent number is the sum of the previous two. So here are the first 10 numbers of the Fibonacci sequence. We have 0, we have 1. The third number adds up 0 and 1 and gets 1. The fourth number adds up 1 and 1 and gets 2. The next number adds up 2 and 1 and gets 3. Next number adds up 3 and 2 and gets 5, and so on and so on. And I pulled up a list of the Fibonacci numbers up to like 300 or something. Man, they get really big. But the list that I'm using, I do want to note that it's 0 indexed in the way that arrays are 0 indexed. So the solution that I'm going to be working towards is a solution where n starts at 0. All right, so in Fibonacci, the prompt is that I want to write a function that accepts the number n and returns the number at that position in the Fibonacci sequence. So for instance, if we're working from a 0 index, 0 would be 0, then we'd have, this would be n equals 1, n equals 2, n equals 3, n equals 4, n equals 5. So given that n, for instance, if I was given, well, let's see, n equals 5, n equals 6. So given n equals 6, my function should return 8. Given n equals 7, my function should return 13. All right, so one thing I know is that I'm going to have a function. So I'm going to go ahead and structure out the function so I have somewhere to pseudocode. I don't know if that's the right spelling of it. I feel like I always misspell Fibonacci. And I know that that function is going to take one parameter, n, which is the number we're trying to find in the sequence. So I'm going to go ahead and define that parameter. So it could be asked, what happens if the user gives us a negative number, in which case we would have to give them some kind of rejection or error because there aren't any negative numbers in the sequence. There aren't, obviously we can't go below the 0 index, the 0th index of the sequence. And you could also ask, well, what if they give us a word, some other kind of input? Those would be valid questions. For right now, since I'm also playing the part of the interviewer, I'm just going to say that the user will only give us positive numbers. And then let's see, we know it returns the number at that position in the Fibonacci sequence. So our input is n, the index that it's at, and our output is returning the number at that index. In terms of considering different approaches, this is usually solved using something called recursion. Recursion is when a function calls itself to break down the problem into smaller problems. So often people will call in Fibonacci inside of itself as a way of, they essentially find the value for different indexes and then they add them back up until they get to the final one. I'm going to choose to try doing it non-recursively because I've solved it recursively before, and I think it'll be a more interesting exercise to do it without recursion. So we know that at its base level, we want to start from 0 and slowly add. We need to sum the last two numbers at each position. So we will need some kind of memory in order to remember what the last numbers were. So I know that I'm going to create an array to hold the sequence. And since it's the last, we need the last number and the number before that. I think that we'll actually need to start with 0 and 1. Because if we're given 0 or 1, we won't be able to generate that sum because we won't have anything to sum it from. So I think that actually I'll have two cases at the top that if the user gives us 0 or 1, I'm just going to go ahead and return those cases that I already know. Let's see. So I know that usually to solve a recursive problem in a non-recursive way, people will use while loops. I think I'll probably have some kind of looping structure like that that says while. So I think I'll have a counter variable. That will start actually not from 0, because if you look up here, we've actually taken care of the first two cases, so we don't even have to test those. So it will start from 2. And we'll say while our counter variable is less than n. So until we've reached that position in the sequence, we're going to do some code inside of here. And we know that we definitely need to sum last two numbers. We need to sum up the two numbers that came before this one. And then we need to store it. We need to store some in our storage array. And then at the end, we'll want to return our final value for sum. And this makes me think I'll probably declare a sum variable above and not give it an initial value, just so that we don't have to be recreating the sum variable with each loop of the while loop. All right, so I think that this is approaching a solution that I could start to code with. One thing that I'm not sure about, and I'm actually, once I get this pseudocode a little bit better, I'm going to have to figure out if while the counter is less than n, if I want it to be less than n or less than or equal to n. But let's go ahead and I'm going to take care of these base cases up here. So I'll say if n equals 0, return 0. If n equals 1, return 1. All right, I think I'm probably going to need to do a wrap up in like 3 minutes. So I'm trying to think. I might start coding, and unfortunately, because of time, I don't know if I have enough time to go through, walk through what the outputs would look like. But we'll be able to. I'm going to use the console to figure out if it works or not. Which is not best practices in an interview, but it's what we'll do for right now. So if n equals 0, return 0. If n equals 1, return 1. So var, I'm going to call my counter I, like I usually do. It's going to start at 2. And then I'll declare sum. And I'll create my storage array. I'm going to call it, I usually call this kind of array memo for memory, whenever I'm just kind of storing things as a way of remembering them in my function. So while I is less than n, I'm going to sum the last 2 numbers. So this actually would be better rephrased as assign sum to the sum of the last 2 elements in memo. So I'll say sum equals memo I minus 1, so the last element, plus memo I minus 2, so 2 elements ago, the last element and the element before that. So now we have the correct value for sum, and I'm going to go ahead and push sum into my memo so that I have it in there as I continue to move forward in the sequence. And then at the end, once we've met our condition, we'll just return that final value of sum. All right. So if this condition is correct, hey, Jordan, would you mind, can you ping the Slack channel just to let everyone else know to join up if they haven't? Thanks.
Yeah, I'll do it.
All right, so I'm going to choose a number from here. 0, 1, 2, 3, 4, 5, 6. So let's try int Fibonacci 6, and we should get 8. Oh, I bet I spelled it wrong. Or did I not? Invalid array. Oh, I think I created an infinite loop. Ah, does anybody see what I did wrong? Let's see if I can find the chat. In my rush to a solution, this is why it would have been helpful to walk through. I forgot to increment my counter. Yeah, exactly, Josh. All right, let's try this one more time. Oh, whoops. I pushed memo instead of sum each time. All right, cool. So now we're getting closer. It is currently 1 element off. 0, 1, 2, 3, 4, 5, 6. So I think we need to say if I is less than or equal to n. Cool. So I think this works. Let's see if it gets 13 next. So let's see, 7, 8, 9. So 34. Cool. All right. So that solution works. I will post the recording of that. I don't want to spoil it for anybody that's coming in that didn't want to see it. I will post a recording of that to the whiteboard. Awesome. So let's see. How